Hello everyone! Today, we'll show you the PYNQ function demo for Puzhi's P047 and P047Pro boards. Before the official demo, we need to complete preparations first. First, get the PYNQ image file we provide, and use a dedicated flashing tool to burn the image to an SD card. After flashing, refer to the attached documentation to install and import the PYNQ demo. What I'm holding here is a bare test board. The production versions of the P047 and P047Pro boards will ship with a protective enclosure. For today's demo, I've pre-installed the demos, so we'll jump right into the hardware setup process. Step 1. Insert the SD card into the board's SD slot. Now, these 3 dip switches control the boot mode. Today, we've set them to 1 and 0 and 1 mode, which selects SD card boot. As per the boot mode table, the final Puzhi's enclosure will have clear 0 or 1 silkscreen labels, so you can easily set the switches correctly. Next to these is another dip switch for clock selection. It lets you choose between the internal clock, which uses a 19.2 MHz crystal oscillator, and an external clock input. We're using the internal clock by default today. Alright, let's connect the power adapter to the board first. Next, the Type-C cable. Our board's Type-C port combines JTAG and UART functions, so we can use this UART to view debug prints. Then, connect an Ethernet cable to the board. PYNQ interactions happen through this Ethernet port. Note, you'll need a router. Connect both the board's Ethernet port and your computer's Ethernet port to the same router to create a local network. The router will assign an IP address to the board, which we'll use to access it later. Once all connections are in place, power on the board. After powering on, open your computer's device manager. You can find it by searching for Device Manager. In the system search bar, look for the UART port number. Mine shows COM5. If you're unsure which port it is, unplug and re-plug the Type-C cable. The port will disappear and reappear, confirming the correct one. Once the port is confirmed, open your serial tool. Okay, select serial from the protocol drop-down, then pick COM5 from the port list. Set the baud rate to 115/00 and uncheck the flow control option. Click Connect. Since the board's already been powered on and running for a bit, just hit Enter to bring up the board's command output. Then type ifconfig to retrieve the board's IP address. Now you can see the IP address displayed on the screen. Open your browser, type in your board's IP address, and add the port number 9090. Press Enter to access the interface. Then enter the password ZYNQ. Hit Enter again to load the page. In the browser address bar, replace tree with lab after the IP. Wait a moment, you'll enter the PYNQ operation interface. Once inside, you'll see pre-installed demos in the file directory, such as PYNQ-NCO, RFSOC book, RFSOC OFDM, RFSOC QPSK, and RFSOC radio. These demos are preloaded for today's demo, and users will need to import them, following our documentation. Now let's show how they run. Let's start with the demos in the book directory. First, run the NCO demo. There's a single step arrow on the interface. Keep clicking it to run step by step. Alternatively, click the double triangle auto run arrow to let it complete the entire process automatically. After finishing either manually or automatically, check the results. The interface will display numbers step by step. No errors mean the process is running smoothly. When it shows execution completed, the demo test passes. This is a basic function test that doesn't use the RF module. Next, the radio demo, which requires RF. It enables sending and receiving text strings and images. Before starting, connect an RF cable. This demo won't work without it. Take an RF cable and connect it between the ADC and DAC ports. We're using ADC channel ADC22501 and DAC channel DAC22900. Once you've confirmed the channels, tighten the cable onto each port. After connecting, click the Auto Run button to let it complete the process. Please wait. This takes a moment as the system dynamically loads the bitstream file. After the loading is finished, the demo will run automatically. As you can see, it complete BPSK and QPSK synchronization tests, with all results showing successful. Once the first step is done, the subsequent processes will run much faster. Scroll down to find more tests, such as digital transmission and reception. At the bottom, there's an image transmission test. It sends a CAD image, and the received image appears below. You can also use single-step mode to test this process. We're just doing a quick demo here. Finally, let's run the OFDM demo. Again, click the Auto Run button. Select Restart and let it proceed. First, it loads the bitstream file. Please wait a moment. After loading is complete, you can see that the default modulation mode is BPSK. Click the Run arrow, and you'll see the corresponding phase signal on the page. You can also switch between different modulation schemes, such as 16QM, 32QM, and others to conduct relevant performance tests. That concludes the demo of the board's main PYNQ functions. There are other demos you can try on your own. Note, this board runs the open source PYNQ platform firmware ported from Xilinx. Beyond our provided demos, you can develop your own applications on this platform. Our demo wraps up here. Thanks for watching.